Okay, so lesson 7.01 was about hydrocarbons, and so far we've talked about alkenes, alkynes, functional groups, things like that. But something else you need to be familiar with is the idea of an isomer. All right, so just a quick review from the last lesson. See if you can name these two compounds. All right, start with this one. We actually had you the name in the last video, so if you remember, you count up how many carbons there are. All right, so there's 6 carbons, which means your prefix needs to stand for 6, so it's hex. And then everything is single bonded, so that means there's an ane ending. See if you can name this one. So you've got 1, 2, 3. Prefix for 3 is prop. And then this double bond means that you're dealing with an alkene, so your suffix will be propene. All right. And then we also talked about a bunch of different functional groups like carboxylic acids and alcohols and aldehydes and ethers and all those sorts of things. So see if you can correctly identify which functional group is present here. That is an alcohol. And then oxygen with carbon single bonds on both sides is called an ether. That's just a quick review, easy sort of thing there. So, I want you to think about how you would name these two compounds. All right, I'd go 1, 2, 3, 4. All right, there's 4 carbons, so I'd say bute, and they're all single bonded, so I'd say butane. Here I've got 1, 2, 3, 4 carbons, and they're all single bonded. So you know what, I would name that butane as well. But are those the same compound? No, they're not. All right, these are going to have different properties. This one, it had this branch, all right, is going to make it so that this compound, it's going to have weaker intermolecular forces because that branch is going to prevent these from lining up to each other really nicely. So this is where that term isomer comes in. So hydrocarbons that have enough carbons are able to produce isomers. And by definition, an isomer has the same formula. Mind you, this is a structural isomer. Have the exact same formula, but different connections. All right? How you can tell if you've actually correctly set up the connections differently is that they are non-superimposable, which means there's no way I can rotate, flip, just kind of shift around isobutane to make it line up perfectly with regular butane. It's not possible. All right? So your task going forward is going to be how to spot when something is an isomer, so it's going to have the same formula, just different connections, or if it actually is a totally different compound with a new and unique formula. All right, so here's your first way of kind of dealing with this. So which of the following is not an isomer of the rest? All right, so which one of these would have a different formula than the other ones? So I find the easiest way to deal with this is to first count up how many of each atom are present in the picture. All right, so here I've got 1, 2, 3, 4, 5 carbons. So this is C5, H10. Oh, nope, sorry. H12. All right, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so let's count this one. I've got 1, 2, 3, 4, 5 carbons. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So far, those two are isomers of each other. This one down here, I've got 1, 2, 3, 4, 5. So 5 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you were thinking that maybe this one was going to not be the isomer because of that double bond, that was really good intuition. But let's confirm it. I've got 1, 2, 3, 4, 5 carbons. But that bond, if you remember, we talked about saturation and unsaturated. When you add that double bond, that's going to take away some of the hydrogens. So now we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. All right, so this is our non-isomer. This is actually a totally different compound because it has a different number of hydrogens. The other 3 have the exact same formula, and they are structural isomers of each other. So, see if you can spot the correct isomer of this compound. CH2, double bonded to CH, single bonded to CH2, single bonded to CH3. Right. Again, I recommend start with a count. We've got 1, 2, 3, 4 carbons. 2, 3, 4, 5, 6, 7, 8 hydrogens. All right, so go through, count up what's in these other formulas and see if you can find one that is, C4H8. All right, so got 1, 2, 3, 4. These all have 4 carbons. So it's my hydrogens that are going to change things. 3, 4, 5, 6, 7, 8. That looks promising. 3, 4, 5, 6, 7, 8, 9. Definitely not that one. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I can definitely cross out those 2. But now I want you to look at these next 2 really, really, really carefully. Which one of those is not superimposable? Meaning I could line it up on top of this one, you know, either rotating it or flipping it or whatever. I can line it up or on top of that and they will never match up. All right, I am hoping that you said the first one. All right, the reason for that is this compound, all it is this exact same structure flipped. All right, so if I were to rewrite this backwards, CH2, CH, CH2, CH3, those 2 are the exact same thing. All right, this one, written forward or backwards, has this double bond in the middle, which means you can't get it to superimpose on top of the formula in the question, so that's the only one that is a structural isomer. All right, one more practice one. Which formula represents an isomer of CH3 connected to CH2 connected to COOH? Before you get going on that, a bonus review thing, which functional group is COOH? Also can be drawn like this. If you said carboxylic acid, you are right. So now let's focus on the question at hand. We've got 1, 2, 3 carbons, 3, 4, 5, 6 hydrogens, and 2 oxygens. All right, so go through, count up what you see in here, see if you can figure out which one would be your correct isomer of this one. I'll have the same formula, just different connections. All right, so let's look at carbons first. I see 1, 2, 3, 4. There's 4 carbons there. This doesn't work. I need only 3. So here I've got 1, 2, 3. That's a good sign. I've got 6 hydrogens and 2 oxygens. This is looking promising, but let's continue, make sure. Got 1, 2, 3, 4. Nope, C4 again, so that's not gonna work. I've got 1, 2, 3. And then my hydrogens, I have 1, 6, 7, and only 1 oxygen. So the only one that has the exact same formula but different connections is B.